Hello, everyone. It's today my pleasure to welcome you all to today's virtual masterclass, which is titled Environmental Education and Advocacy, focusing on regenerative agriculture and food system transformation, a very important topic. It's my pleasure to welcome you all and to moderate together with Callista Ndulu from the HSF Kenya. I'm based at the HSF Namibia, and I am the project manager of the Global Project for Mitigation and Adaptation to Climate Change, or in short, we call it the GMACC project, which actually should be familiar to all of you. But if you don't know me, my name is Dr. Lara Bier, and we have created this virtual masterclass series. So today's session is part of a broader series we have developed through the Think Global Sustainability Network, which is our platform for connecting people, ideas and solutions across regions and sectors in response to climate challenges we are all facing. So we are not only focusing on Africa today, we're having participants from all over the world, from all our regions GMACC is active in, and I'm very happy to see so many faces. Today's focus is regenerative agriculture and food system transformation. And this is not just timely, it's a very essential topic. And in many parts of the global south, communities are dealing with the most severe impacts of climate change, from erratic weather patterns to food insecurity and soil degradation. And at the same time, agriculture remains a major contributor to emissions and ecosystem loss. So what that tells us is clear. The way we grow, distribute, and consume foods needs to change. Not gradually, but fundamentally. And regenerative agriculture offers here a path forward. It's not just about sustainable practices, it's about restoring ecosystems, rebuilding soil health, and strengthening the resilience of farmers and food systems. It's about moving from extraction to regeneration, and from short-term gains to long-term well-being. But for all these ideas to take root, we also need strong environmental education and effective advocacy. So we need people like all of you here today who are informed, engaged, and ready to lead change in your communities, sectors, and regions. So from wherever you're joining us today, thank you so much for availing yourself. Your participation reflects a very shared commitment to solutions that are not only technically sound, but socially and ecologically just. On behalf of the GMACC project and the entire Hans Eidel Foundation, I hope today's masterclass gives you fresh insights, new connections, and practical ideas you can take forward in your work. Thank you very much for being here today. And let's get started, and over to our moderator, Callista.
Well, thank you so much, Dr. Laura Bier. My name is Callista. I'm based at the Hans Eidel Foundation Nairobi office, and I'm also the coordinator for GMACC Taking Care of Africa. Without much ado, I would like to give the floor to our first presenter, who is Madam Lucretia Mwangi, to take us through soil health, biodiversity, and agroecological methods. Over to you, Lucretia.
Thank you so much, Callista. Let me share my screen. I hope you can be able to see my screen.
Yes, we can.
Okay, thank you so much. Yes, like you've heard, my name is Lucretia Nyawera, and I'm very excited to be part of this webinar today, where we look forward to sharing knowledge and ideas around soil health and biodiversity. My work involves working closely with farmers, with researchers and other stakeholders in matters of soil health, in matters of biodiversity, which are the key contributors to the agroecological ecosystems. I'm currently working at C4ICRAF in the land and health field, and I'm going to talk about soil health, biodiversity, and agroecological methods. I want to switch off my camera now because it might interfere with my internet. Yes. Yeah, did you all know that over 95% of our food comes from soil directly or indirectly? Soil is very critical in our food system, and most of the food that we take, including cereals, vegetables, etc., and even meat, comes from the soils. It's therefore very critical to emphasize the need to protect our soils. And this is a challenge because there have been increasing challenges in terms of climate change and land degradation. And according to a report by PBS, it shows that land degradation threatens the livelihoods and food and nutrition security of over 3.2 people globally. There's also a lot of decline in biodiversity and soil fertility, and this creates a very urgent need to create resilient and sustainable food systems. Soil health is the bedrock for sustainable development, and this grounds our aspiration for a better world through the achievement of SDGs. We find that soil health supports SDG, Sustainable Development Goal 1, 3, 6, 13, 15, 17, and this emphasizes the need to take care of our soils. And we cannot talk about soil health without talking about soil life. And so biodiversity is the variation in life that is found in the soil. We find that soil is a habitat to over 25% of all the global species that we have. And this ranges from what you can see, the macrofauna, to the microorganisms that you need microscope or other ways to be able to see them. And this is a picture of some of the things that we find living freely in the soil. And this takes us to the next slides where we see that we have living soil and we have dead soil. When you talk about living soil is where these organisms are present and are abundant. And if you take a teaspoon of healthy soil, it has billions of bacteria, millions of fungi, and so many other diverse organisms freely living in it. And where this is present, where these living organisms are present, there's efficient decomposition, and decomposition contributes to nutrient-dense soils, and thus increasing the plant productivity. The contrary is true, where the soil is dead, we find very minimal organisms living in it. The rate of decomposition is very minimal or compromised, and this will consequently influence plant productivity. And so we find out that we have different categories of soil biodiversity, and these are classified based on their sizes. Like I said, when you dig your soil, you will find earthworms, centipedes, millipedes, and these are not just there for the sake of it. They have very critical role that they play in our soils. And these that you can see, they are called macrofauna. There are so many of them living in the soil, and they have very diverse role, including creating barriers and channels that ensure soil aeration and water infiltration. Other category that we find are mesofauna, and examples of these are springtail. You can also see them through the naked eyes, but they are smaller than the macrofauna, and these contribute to the decomposition rates in the soil. Then we have microfauna. You need microscopy and other forms of tools to be able to observe them, including nematodes. We have tardigrades, we have rotifers, and these mostly are biological controllers within the ecosystem. They ensure that we have a balance within the soil ecosystem. And we have microorganisms, the likes of bacteria, fungi, archaea, which are very critical in terms of nutrient cycling. Bacteria will fix nitrogen that is freely available in the atmosphere. We have fungi forming a symbiotic relationship with plant roots, etc. And so collectively, they all contribute to soil health and climate change. The way they do it is through enhancing soil structure, like we've seen earthworms and termites will improve aeration, aggregation, and nutrient cycling. We have organisms fixing nitrogen, forming symbiotic relationships, carbon sequestration, and also climate regulation. Archaea will lead to methane oxidation, contributing to climate change mitigation efforts. So jump over to agroecology. We find that agroecology, simply put, is just working with nature and not against it. And it also can be termed as growing food in a way that cares for the soil, that protects biodiversity that we've spoken about. And this usually recommends using very few chemicals or none and supports farmers and community. And it combines ecological principle with local farming knowledge to create sustainable, healthy, and food systems. And therefore, there are 10 agroecological principles that have been put forward by FAO. I believe the subsequent speakers are going to speak more on this. And this usually aims to integrate ecological science into farming as well as build on traditional knowledge and local context. Some of the agroecological methods that we know and we want to remind ourselves about is crop rotation, agroforestry systems, and I see for a graph we really emphasize on agroforestry because we are more of an agroforestry organization. We have cover crops, and if we apply sustainable soil management practices, we can boost food productivity by over 58%. And this includes minimizing soil disturbance. As we've seen, the organisms that live in the soil are very sensitive to disturbances, and also enriching soil with organic matter, which improves soil health, leading to better yields and increased resilience to environmental stresses. So there are synergies between agroecology, biodiversity, and soil health, because we know that agroecological methods create favorable conditions for soil biodiversity. Soil biodiversity, on the other hand, enhances ecosystem functions, and this leads to improved soil health. So when we talk about the three, they work together. You cannot talk about soil biodiversity if you're not practicing agroecological methods, because the life in the soil would definitely not be able to flourish. This slide, I'm going to talk about some of the work that we've done as CIFOICRAF and give examples of how farming system influences the life that is in the soil. And these sites were from India, and we received these soils in our labs for analysis, where we were looking at Ambascura mycorrhiza fungi, a type of fungi that freely lives in all soil types, and it's beneficial. None of its species is harmful to the soil or to the plant. And the farming or the agroecology method that they use is called Pradesh community managed natural farming, where farmers have come together and they advocate for very minimal disturbance of the soil, no synthetic fertilizers or pesticides, leaving the soil covered throughout the year with cover crops and mixed farming. And we did comparison to adjacent plots where this was not done. And we found that where over a period of 3 years, we were able to see changes in terms of earthworms and also in terms of Ambascura mycorrhiza fungi. And the crop yields also went up. There was 40% increase in cotton production, 30% in paddy crops, and 65% in groundnut. And this is still from the same sites where the spore abundance or the mycorrhiza was up, where we had practices of natural farming. And this is also for the earthworms where we had this and where we didn't have this natural farming system. And now I want to talk about how we measure soil health at CIFOICRAF. because you cannot improve what you've not mentioned. And I'm going to talk about a tool that we use. It's called LDSF, or Land Degradation Surveillance Framework. It's a tool that monitors soil health in terms of soil organic carbon, total nitrogen, infiltration capacity, and now we also have soil biodiversity, where we measure the ambassador mycorrhiza fungi, the bacteria that is present, the fungi, the nematodes, the earthworms, etc. And this is more about the tool, and it's more of a sampling tool that is systematic and hierarchical, and we apply it across our project site. And as we see here, we don't only assess the soil health, because the above ground will reflect what is happening below ground. We look at the land degradation levels, we look at the land use, the impact on habitat, also soil erosion, etc. And we have applied this tool consistently in over 250 sites. So yes, these are some of the dotted green areas are some of the project sites where LDSF has been applied in more than 45 countries so far, and we use it consistently. We use the same principle across the projects, and this helps in statistical comparison across land uses, and also the correction of field data. You see people here in the field correcting data enables production of accurate predictive maps. And LDSF manual is available to everyone. That's the link for the LDSF manual. So there are several factors that affect soil organisms, and some of these that we have found from various studies that we've carried on here at ICRAF is the presence of tree and also the diversity. There was a study that was done here that was looking at the impact or the effect of different tree species on macrofauna. The student was looking at how different trees will affect earthworms and beetles. And what was coming out from the study is different tree species have different effect on macrofauna, emphasizing the need to have a diverse cover of trees. So if you're having your farm, it's recommendable, if you're practicing agroforestry, to put different agroforestry trees rather than just putting one tree. Also the soil type and some soil sampling time. If you want to analyze soil life, you need to be careful about the sampling time and the storage period, because some of these are very sensitive to loss of moisture, etc. And also soil pH and carbon content affect most of the life that are in the soil. For instance, the earthworms tend to survive in 6.5 pH. If you go beyond these, if your soil is becoming acidic, then you start losing the life that is in the soil. And also solar radiation, if you're leaving your soil uncovered over long periods of time, the organisms are not able to survive because of the direct effect of radiation. And also we have human activities. Like one of the major one is use of pesticides. Like here, you find most of the farmers will look at some of these organisms as pests, but they're not. So a farmer who is using pesticides, for instance, to control nematodes, they are killing the beneficial nematodes with the harmful. And most of our study has shown that out of all the nematodes we have, only 1% is harmful to the plants. So we ask ourselves, should we destroy the 99 other beneficial organisms with the just one, rather than looking for other ways of other biological control of these organisms? And also tillage and burning of vegetation. these are some of the factors that affect our soil organisms. So in conclusion, we see that agroecology and biodiversity underpin sustainable agriculture, and agroecology offers practical, inclusive solutions, and collaboration innovation is needed. And preserving biodiversity, as we've seen, is critical for future food and ecosystem security. Those are some of the references. And thank you so much, Corista. I'm done.
Thank you so much, Madam Mwangi. We really appreciate your time. Quite detailed, but I don't want to get into the details unless there is a question. And from the chat box, I'm not seeing any question. So please let's put our questions on the chat box so that we can be able to respond to them. And given that no one has asked any question, I would like to invite the second speaker, who is Dr. Kennedy, who is going to take us through linking agroforestry to sustainable food systems. Dr. Kennedy, make sure you operate within your time.
Okay, thank you. I hope you are able to see the slide.
Yes, we are.
Let me do that. That's perfect.
Yes, it is.
As you've been told, my name is Kennedy Olale. I'm happy to join the webinar today. Currently, I'm a lecturer at Kisii University. I'm a former research fellow at the World Agroforestry Center. And I'm happy to come and give a presentation on linking agroecology and sustainable food systems, and giving it an approach where we look at the role of chemical sciences, or chemical sciences approach, in giving us the linkage that we have, and also working towards a healthier planet. And particularly, we are looking at the sustainable chemistry in its three overlapping aspects, that is both the environment, society, and also the economy, to help us understand how we can link the agroecology with sustainable food systems. Now, what we are interested in is to apply the same principle of sustainable chemistry by tapping in what exists within the plant volatiles. We are considering the key aspects of resource and the production, and also the product recycling. So we look at the role that the chemical sciences plays, especially in enhancing agroecology and also food systems, by providing the tools and approaches that can help us minimize the environmental impact, while at the same time we are promoting food security. Now, it is the chemistry that underpins the agroecology by helping us understand the issue of soil nutrient, the nutrient recycling, the interactions that we have in between this kind of plants. So it is important that for us to minimize this impact, we are also working towards the promoting food security in the same aspect. Now, now it's okay. Now, the most important thing is to check out what are the underlying, or what are the chemical principles that we can now adopt. Because once we adopt these sustainable practices, it is important that we look at the agroecology in terms of the principles, the chemical principles that we have, and the role that they can help us in understanding this. Now, look, for example, the issue of the soil health. I think this is the slide here, the soil health. If you look at the soil health, we are looking at how are we able to maintain or give or have a healthy soil, and at the same time, we are also maintaining the healthy plants by just applying the chemical principles, because you cannot study the principles, or you cannot study the agroecology and leave out the idea of the chemistry in its management, because it is the one that is going to help us understand the soil health. It's going to help us understand the issue, why are we integrating the crops with it? It's going to help us, how are we going to have the water management system by having a system that is more sustainable in terms of the water use. We have plants that are going to be useful in terms of the if you are recycling wastewaters, you need some plants that can act as phytoextractors. So we want to minimize the reliance on synthetic chemicals. And at the same time, we are promoting the natural processes. So we look at the pathways, the ecological pathways that can lead to sustainable food system. So by just understanding how we apply the chemical principles, then we can enhance all the principles that we have of agroecology, and also can also help us in terms of even the pest control. We have to involve the community because from the research perspective or from the academia, sometimes you find that if you don't involve the communities and you develop the techniques in the lab, then it becomes a big challenge when it comes to its implementation. So the agroecology here represents the all the what we call the holistic approach that we can use in sustainable applications of this science. We are tapping into the plant volatiles that will help us in terms of management of these pesticides. Again, we are also tapping into the systems that are able. The principle is to minimize a lot of synthetic fertilizers, synthetic chemicals into the production or bringing them into the practices and the principles that agroecology embraces. Now, a practical application or a practical example is when we look at now the plant interactions, and this is the most interesting thing here. Now, we are tapping again into the volatiles that are coming from particular plants in between a system, a cropping system, where you plant the desmodium, which gives a volatile component that repels the pesticides, and at the same time, we are planting the border crops around here that are also generating some components, especially the Napier grass, that are now generating the volatile fatty acids that are now able to attract, or they are able to pull the moths or the moths that have been expelled from the plant. So in this kind of a system where we are just relying on a natural system, you will find that there is an intercropping where a Napier grass and a legume like desmodium are planted in between different rows, and the volatile components, the terpenoids that are coming from the desmodium here, are repelling. They are pushing, or they are repelling the egg-laying moths away from the plant. And at the same age where we have the Napier grass that is also giving the volatile fatty acids that are also attractive to this the moths or the moth-laying eggs, it pulls them towards the end. So in a way, we are having a sustainable system that minimizes environmental effect. So the idea is to maximum the control efficacy, and at the same time, we maximize on the efficiency. So here, there is no need of using those expensive chemicals. You can use some plants and you capitalize on excretion, what those volatile compounds or what those kind of plants are able to excrete, and how it involves the pest management. So there are some pests that are going to be repelled, and at the same time, they are taken towards the borderlines, where you also have the likes of Napier grass, and that is where now they are able to go. So it is more of a sustainable way in which you are able to move some of these insects away, or some of these moths away from the plants, and at the same time, you are maintaining your crops in that kind of a system. So it is a practical example where you don't even need to use chemicals, but at the same time, you are able to manage your crops well. Now, in doing this, you realize that it is the chemical sciences that will going to create a sustainable food system. We are going to have a system, or it brings about the system that is sustainable by optimizing now the agricultural practices, and then we enhance the food processes and also the processing techniques. Now, how is this one possible? It is possible because what happens is that as the world population is expected to grow, and it is estimated that by around 2050 we'll be having 9.5 or 9.4 billion population, or 9.4 billion people to feed. There is going to be pressure on our food system. But how do we ensure food security while at the same time we are maintaining environmental sustainability? So we must have strategies, or we must create or promote strategies that enhances ecological interactions and synergies that are between the different components of the farming systems. Now, we need to have improved environmental health to reduce the pollution. For a sustainable food system, we also need to increase economic viabilities for both the farmers and also the businessmen. And at the same time, we need to strengthen our social equity by addressing the food access and also affordability. And lastly, we also need to look at the human health in terms of the nutrition and address the complex idea of the food system. Now, sometimes even getting nutritious fruits requires healthy management of the fruits, because at the same time, if you look at some of these chemicals that we have that are used for food ripening, they still end up being transferred to humans. So they are chemically induced ripening, like the carbides that are commercially bought, the chemicals called the carbides that you use to induce fruit ripening. So we need to come away from the chemical use in terms of inducing food ripening to naturally, or some plant-based ethylenes. There are some plants that emit ethylene that when you put together with your fruits, it also enhances ripening. So that the main goal is to get good nutrition and get healthy fruits. So we don't want to use a system where we are leaving some chemical footprint. So we must use, we have to avoid the chemically induced ripening fruits. We also have to reduce the use of pesticides. We also have to look at the issue of heavy metal contaminations from this kind of fruits. Now, to enhance all this, we need a sustainable processing, because in the terms of even the value addition for our fruits or our plants, we need a system that is able not only to preserve and also to process, but we also need to use some sustainable materials that we can use in packaging, the sustainable materials that we can use in food processing, food packaging, so that at the end of it, we rely on these technologies that minimize the environmental impact. So we have to strike a balance in manufacturing in terms of the output and also ensuring the environmental cleanliness from the farm to the shelf and again for consumption. So we are looking at the system that's also going to be a technology that is going to minimize the impact all through. Now, the same technologies that we are going to use in the processing must also take care of the food safety. We must use the eco-friendly packaging materials, and also we must adopt some innovative technologies that can also help us have the food stored without necessarily using some things that are not degradable. Now, moving into the future, there is also a need for us to have replacements, what we call the alternatives, for either precision farming or again for what we call the green manufacturing, in a system that we replace the well-known chemicals that farmers already know. I'm sure some of them have interacted with, they have been involved in some farmer technology transfer training and also taking some technologies to farmers. You find that they have a list of chemicals that they have mastered and they have already known that this one I have to use in doing this I have to use in doing this. So the idea is, how do we bring in the issue of natural alternatives to these farmers? When we are talking about the antibiotics, what do we need? When we are talking about the hormonal promoters, what are the alternatives that are able to do this? We look at the chemicals, insecticides that they're using. We have to come with some alternatives so that we have a system that is not chemically polluted, but we are talking about a system that is able to run well without pollution from either the chemicals that the farmers are buying or the farmers themselves getting intoxicated through the pesticides that they are using in maintaining their crop yield. Of course, even the fertilizers are also factors here, because it is also estimated that without the use of fertilizers, of course, there will be a decline in the food security and also the decline in the food production. So how do we give the farmers a green alternative? So the idea is to use the chemical knowledge in developing alternatives for farmers so that they are able to know that without buying the inorganic expensive fertilizers, we can make our own. There are different kinds of plants that are so rich in nitrogen that if you can use, they can also supplement the nitrogen in your farms. And again, not forgetting the use of or the practice of agroecological principles that will help us maintain healthy soils and also healthy crop yield. So looking into the future and also prospecting into the future trends, yes, there is a problem, and we are trying to move from what we know to even where we are now interested in involving the communities, because we must engage more of these communities so that they are able to upscale, to uptake the technologies that either we are developing in the lab, and then they are able to use them. Right now, there is a current feature research that people are going towards the use of AI in precision agriculture. The issue is, are we going to leave it at the lab, or at what stage are we going to also bring the community to be involved so that we do the precision agriculture with the use of AI? They are able now to know exactly that this is the amount of water that my plants need. This is the kind of pesticide that I'm supposed to apply and at what time. Finally, as we look at the way forward, yes, it is important that agroecology is a key to sustainable food systems, but we also need all the stakeholders. We need to move from our labs. We need to also go out to the field and also engage the community so that they take ownership of the techniques that we develop in the lab. For example, case in study is the one where I had shown the planting of desmodium and also the napier grass in between the plants, and then you have to take the technology to the farmers and train them so that they're able to adopt onto it and also use this kind of sustainable practices. Again, in terms of the soil nutrient management, we also need to develop kits that can be taken back to the farmers, that they are able just to use from the kit. You can test your soil pH, you can test your soil parameters without having a knowledge of chemistry or chemical sciences. But the kits that we are able to develop is able to help you move forward, and then you are able to get the exact, to know what kind of what kind of fertilizers you will need for your soil, what kind of pH is your soil, so that we minimize the use of these agrochemicals and we preserve our ecosystem. And finally, we need to think then globally, but at the same time acting locally by now bringing the local people who are implementing this and giving them these technologies to see how they work. Otherwise, if we develop these technologies without involving the farmers, then chances are that the technologies will be left in the lab and adoption will be a challenge moving forward. Thank you, and I'm sorry for the interruption that had occurred because of the power.
Okay, thank you very much, Dr. Kennedy, for that very impressive presentation. Are there any questions? I haven't seen any in the chat box. Otherwise, you will also have the opportunity to ask your question later after our last presentation or comment. Then I would say let us hand over to Isifu Zifo, please share a screen. The floor is yours.
Yes. Okay, so I want to thank you all. We've had beautiful lectures. Anywhere at all I will go, I will hear people talking about agroecology. It's good. They say every good thing about it, but the fundamental question is, why is it not a leading food policy in the global food policy agenda? Because everywhere you go, that's why everybody is talking. It's good, it gives us healthy food, it promotes environmental sustainability, yet it is not a leading food policy when it comes to when we look at the global food policy agenda. So that is what I'll be looking at. And let me share my screen. Yes, I can get off for the sake of internet so that I don't repeat what my brother was going through. Okay, so my name is Isufu Sulemana. I'm still struggling to find my video link now and then off it. My name is Isufu Sulemana. Let me say I'm a farmer, an environmentalist. I work with farmers. I am also a team lead of a small organization called Center for Ecological Agriculture and Livelihood. We are based in Walwale. So based on the question I asked, what I'm simply going to do is to tell you from farmer perspective. Please, this is from the farmer perspective. Because everywhere I go, I see everyone preaching. Agroecology is good, agroecology is good, agroecology is good. But when you get to the international level, it is something else. So why? So my topic is advocacy for agroecology and international food policy from the farmer perspective. And then this will be what we'll be discussing. Now, I am guided by 3 questions. The first one is we'll be looking at agroecology in the context of international food policy. We'll look at what is it going on at the international level? The UN, FAO, Regenerative Declaration, IFPRI, and all those who are doing wonderful things about agroecology. The second thing is, I ask, is agroecology really receiving the needed attention? Which is tied to the first question that I asked before I started talking. Then the third one is, how can we push agroecology properly into the global food policy agenda? And when I say that, I mean, what is the role of farmers and other stakeholders like you? So let's look at it in the international policy, food policy arena. My 2 speakers have already said so much about it. It's nicely defined by the UN or the FAO, which we are all aware. That's the 10 elements of agroecology. When you go to the net, you Google, you find them beautiful, defined there. In my opinion, it's quite scientific. And it's also a top-down model. The second one that resonates well with me as a farmer from the local level has to do with the Nyalene Declaration, which is the food forum for food, a forum for food sovereignty. That one is bottom-up model, grassroots, and it resonates very well with me because that's actually what I want to see agroecology being promoted from the grassroots level. There are others, such as IFPRI, Groundswell, Feeble. They are all doing wonderful about agroecology at various levels, from the local level to the national level. But the basic question I ask is this sufficient? And why? Why? Because there are key issues, and those key issues are what we need to look at. And I group them into 2. Some of them are external. External in the sense that we probably do not have so much to influence. Number 1 has to do with the pushback from the multinationals. I don't need to mention names here. You can see them from the screen. And why are they the main issue? Profit. They are driven by profit. And to continue making their profit, they want to have dominance and control. What do I mean by that? They want to make sure that we have a food policy, a food system or a food policy system that ends up putting all of us under their armpit. So you either come to them or you go hungry so that they can continue making their profit. The next one is they will never be in favor of this kind of approach, which is agroecology approach. And remember, agroecology approach is also a development model on its own. That is from bottom up. And why is it so? Especially some of the approaches, the models that we use as farmers is the lesser approach. And the lesser here means you are using less external inputs. In some cases, no external input at all. So if that model is promoted, that means farmers will have nothing to purchase from them. And if you don't buy from them, they're out of business. They will never like this type of approach. Key issues. Others are internal. Internal in the sense that we have the capacity. We could do so much about it. But for one reason or the other, we are not doing it. A typical example has to do with the public trust and ambiguity, because we do not have enough studies available. The simple question some people do ask is, can agroecology actually feed the world? And we cannot answer it. Number two, there are few studies like those that I've mentioned ahead, but they are not disseminated because of the interest of what the current food policies, food systems. Those who have the capacity to promote it and disseminate them are the people who are making money from the, what's the name? The other side of what? Food production system. So they will never be, and they will never give us the chance to do that. Number three, in most cases, it's a farmer-led. And you know, we farmers are scattered all over, so, and we are very weak. And how do we confront our government? And in some cases, the powers be for that policy shift that we are looking for. And I ask myself a question. Until somebody helps me to get to, what's the name, COP or somewhere, where is the space for me to talk? It is not there. So these are some of them. Now, the next slide has to look at, okay, we've looked at all those issues. What is it that we farmers want to see? That is the main issue here. We want to see agroecology being deliberate or intentional. If we are really serious and we are talking about agroecology being the answer to all our food security needs and all the environment, climate change, then we have to be deliberate and intentional. In that, we want to give it, we should work towards, making it giving it a priority attention in the global food policy agenda. We want to see a universal declaration. It's been done. Anytime at all people feel or the whole world think that it is something that requires an urgent attention, they come together to make a universal declaration, and that makes it more serious. Number three, we must work towards making all the world leaders accept it. At the moment, sometimes when you meet them and you are talking, they said yes, but it is not backed by action. Number four, we also have to work to make them set up a dedicated funding mechanism. Look, there was a meeting recently where African countries met to see whether they can commit 10% of their GDP to food production. Ghana couldn't meet that. I give Ghana as an example. That's where I come from. 7%, and out of the 7%, not up to 1% went into promoting agroecology. That is serious. So now the next question is, what are we supposed to do as farmers and stakeholders? So I made few suggestions that we need to intensify our global movement or network building. For me, that is the only way we can build the critical masses and demand for the things that I've mentioned above. We need to have a clear strategy. We need to build capacity. Capacity building could focus on so many areas. For example, I'm just a farmer. There are many farmers out there. Where is the capacity to speak out? They don't have the confidence. They don't have the boldness. We need to present a clear message. We need more public education, targeted advocacy. Gather more evidence. The evidence should either be scientific research or farmer experiences. Such evidence gathering should be guided by the following. One, it should be bottom-up research approach. That means it must be more of what farmer-led, long-term farmer experiences. I give an example as ProEco. It must start from local and indigenous or traditional knowledge, wisdoms and innovations. For example, elephants, farmer to farmer, Groundswell International have good models around this. And later on, scientific institutions like FAO, FPRI, and all those things can come in. So in conclusion, I tell everybody on this platform that we believe in agroecology because we are doing it over so many years and it's working. And it's through this that we believe that the farmer dignity is assured. Thank you. If there are questions, I welcome them.
Thank you so much, Isifu. I was very clear when I was giving this task to you. I was very confident that you deliver without fear. And like you've mentioned, we need these outspoken people when it comes to advocacy. We don't want to give platform to people who are going to be timid when they're supposed to be speaking about fundamental issues. So thank you so much. We have 2 questions on the chat. I think, Linda, I was able to answer you on the bottom-up approach. That is what Isifu was talking about, where you don't just design something and impose it on the farmers. So the opposite is what should happen. The model should be informed by the needs of the community so that there is ownership and that there's success in whatever you're going to do. There's a question that I want to believe you'll go to Dr. Kennedy. Tuaba is asking about the use of chemical fertilizers, where he's saying there's a debate whether chemical fertilizer is authorized, and even some say it is needed. And there's a continuation of the same question where he's asking, you have others who do not recommend using chemical fertilizers at all. What is your perspective on this? To you, Dr. Kennedy.
Thank you. The question of fertilizers is just to put us in it usually puts people in a dilemma between the necessity and sustainability. Yes, it is needed, but overuse is also a problem. So we need to, as much as we need it, there is also need to explore some other options. And it is hard also to get out of the dilemma of the necessity and sustainability. The inorganic fertilizers are cheap. The organic fertilizers that we are supposed to use are expensive. So how do we bridge in between the two? Yes, we need it, but at the same time, we need to upscale the use of organic fertilizers, the production process of organic fertilizers from the inception, and also to minimize the use of the inorganic fertilizers. So there is no a yes or no answer to this, but it just puts us in the dilemma of choosing between the necessity and sustainability, because you can't do away with it, and at the same time, if you don't put fertilizers, of course, you will get low yield. So the continuous use of these fertilizers is what should be avoided. And after the use, there should be a soil regeneration process where you practice or you do the crop rotation that we were talking about. You plant some other crops that are nitrogen fixing so that we don't over-rely so much on the fertilizer.
Well, thank you so much. I want to believe my colleague is answered.
Unless we also have an experience from the farmer, Isip.
Isip, what is your perspective on that?
Okay, so if I got the question well, Chwamba is trying to find out that at this point, chemical fertilizer has now gone into our lifestyle or production to the extent that it's difficult to do away with it. I know him very well. He's in Burkina Faso. He's our next neighbor. We work together. We have similar farming systems. Yes, what he's saying is true. But you see, it is possible to transition people from chemical fertilizer base to zero, no fertilizer based production. And it's all about the strategy that is used. One, in terms of policy, what if we get up one day and in my advocacy this thing, just as research, we have enough data, we have enough proof that yes, we can do without chemical fertilizer. And therefore, the only food policy that our nation, for example, I've seen other countries now trying to say that, okay, without this thing, it is now the national policy that no more chemical fertilizer. It's only if you want to produce, it must be organic or bio. Please, that's what we farmers have been looking for. We will be able to adapt and we'll start using that. So we can have a complete shift, but it has to be in transition slowly from what I call integrated usage of both until you are totally shift to that. So it's going to be policy, it's going to be the issue of education, it's going to be the issue of practicing, it's going to be the issue of reducing, making those things available and cheaper, and we can easily phase out chemicals.
Thank you so much, Isifu. We've got a question that is coming from Tine in Nigeria. He's asking, hello colleagues, I was wondering if the first presenter has examples of alternative ways to address nematode infestation. This is to you, Madam Mwangi.
Yes, thank you so much for this question. And I will just discuss it and see that most of the nematodes infestation will come because there's an imbalance within the soil ecosystem. So if we ensure soil health, we'll contribute to a more balanced soil ecosystem that the soil can be able to regulate itself. So we have nematodes and bacteria, fungi, all regulating one another because there's the predator-prey balance within the soil ecosystem. But problems start coming in when soil health goes down because then there will be an imbalance. That's when we find nematodes now infesting plants and becoming very pathogenic. We have biological control products that are on the market. We have one that is called BioAct, which is just a bacillus. It's a bacteria that has been grown that when you spray within the soil, it's able to control the nematodes itself. So the nematode infestation will come wherever you find it in your soil, you know you have a problem, there's an imbalance. So you create conducive environment through agroecology methods that will bring back the balance, and these can be able to control themselves. I hope I've answered.
I hope that is clear. We have another question from Dambela. He's asking how many, it's still coming to you, Madam Mwangi. It's asking how many years do you need to see change in soil health improvement?
Yes, I'll give an example from the case study that I presented during the presentation. The changes were able to be evident through the lab analysis over a period of 3 years. So it will depend also with what you're looking for, because different organisms will act differently. Like if you start like agroforestry system, you bring in trees to your farm, or you start cover cropping. If you go and you want to check the nematodes, they will come back very easily because most of them don't die completely within the soil ecosystem, they hibernate. So wherever you bring in conducive environment, they're able to come back and revive very quickly. But if you're checking also things like ambassador mycorrhiza fungi, they will take a period of time. So within 2-3 years, you're able to see the changes when you analyze soil biodiversity.
Wow, thank you. That's a long time. 3 years is not a short time to wait to see improvement. But sometimes is it easy to see change using your naked eye? Like myself, I'm a farmer. What should I see to know that my soil is healthy or my soil is not healthy? And I'm saying this from a perspective of someone who doesn't have this equipment you're showing us there. The things from the lab. I don't have them. But I would like to know, is my soil healthy or not? What should I look out for?
You know, the soil ecosystem works as a system. So for instance, the earthworms, which you can see, they work closely with bacteria, which you cannot see. The bacteria depends on earthworms for their food. So wherever you're seeing earthworms, be sure you have bacteria within your soil ecosystem. So all these macrofauna, they are reflection of the micro, because the micro will depend on the macro for their food. So there are those organisms that you can see and you're able to see, yes, I'm bringing in regenerative practices within my farm, because like earthworm, you just pick and you're able to see it. So if you go to your farm and you're not seeing anything like an earthworm, it's a very serious thing.
Wow, thank you so much. We have more questions coming. Estella from ZIMP is asking, one of the major concerns regarding the transition to agroecology is a fear of reduced yields, which directly impacts farmers' income, particularly for those with small holdings. This highlights a critical need for support model that can mitigate risks during the transition phase. Consequently, there is I'm able to see it clearly. Consequently, there is a strong imperative for policies that actively support agroecological adoption. I think she was just making a comment. Any more questions? So thank you so much, everyone. I would like to take this opportunity to appreciate all of you for finding time to join our masterclass today. And special mention to Dr. Lara for your support, the financial support from GMACC. We don't take it for granted. To our presenters, Madam Mwangi, Dr. Kennedy, and Mr. Isifu, we appreciate you and we really have learned a lot. Only that time was not on our side. I think this would have taken a whole day or more to discuss, and because these are things that we see and they're things that we are able to apply practically. But before we call it off, I would like just to highlight something that Isifu said. I'm also in school, so I've learned that when you're designing programs, unless you involve the community, you are planning to fail. So in our interventions, wherever we are, don't just design something and pass it to the community and expect them to embrace it. You first, in any case, you need to design your intervention methods using inputs from the community, not the other way around. So the community is one that gives you, the community's output becomes your input when you are designing your interventions. So I don't have to say much. We really appreciate all of you. And if there are no more questions and comments, maybe I can give Dr. Lara a chance to say something and then we'll be done.
Thank you so much, college staff, for moderating us through this session. I also appreciate all your availability and time you're spending to attend our events, our online events and our in-person events. And I'm really looking forward to the next engagement with all of you. And last but not least, a big thank you to all our speakers. And I wish you a great day and a good week.